What's the next question? Number 47. A DC shunt generator delivers 45 amps at a terminal voltage of 220 volts. The armature and the shunt field resistance are 0.01 ohm and 44 ohms respectively. The stray losses are 375 watts. The percentage efficiency of the DC generator is dash. So this is not a multiple choice question and we will have to solve it. Now since we have been given a DC shunt generator, let me just draw a rough diagram here. So we have our field winding. We have been given the terminal voltage Vt as 220 volts. The current that passes through here would be I shunt and the current that goes through here would be the armature current. Shunt field resistance, okay, the armature and the shunt field resistances are given to us. So which means Ra is equal to 0.01 ohm. Rsh shunt field, that would be 44 ohms. Alright, so this is what we have so far. We have also got the current here as 45 amps. So this is, let's call this as IL, and that's 45 amps here. We'll mark this point because this point is going to come in useful to us. I'm going to name this as point A. Okay, so we have stray losses given as well. 375 watts. Now since the question mentions losses, we will have to find out the armature loss and field loss as well. The armature and field loss together consists of the copper losses. So copper losses equals the armature loss plus field loss. So the armature losses can be written in terms of current and resistance as Ia square Ra losses plus Ish square Rsh. So that's shunt current, armature current, shunt resistance, armature resistance. This actually is the field. So we can use either word. Okay. So in all of this, let's first calculate the field current that we have. Since the field current corresponds to the terminal voltage given to us, so we can write this as Ish equals to Vt divided by Rsh, voltage by resistance. So that's 220 divided by 44, and that gives us 5 amps. Okay, so we have Ish now. Using Ish and IL, we can calculate what the armature current is. Now, looking at the diagram, armature current equals the field current plus the current the motor delivers, the generator delivers. So we have Ia is equal to, let's see now, that's 5 plus 45, 50 amps. Alright, so now we have Ia, Ish, Ra and Rsh, so we can find out what the copper losses are. So the copper losses equals 50 square times 0.01 plus 5 square into 44. Right, so that's I square times Ra, which is 0.01, plus Ish is 5. So 5 square into Rsh, which is 44. So if we solve this, we get a value of 1125 watts. Okay, so this will now give us the total losses. So the total losses would be copper loss, the copper losses that we just found, plus the stray losses that is given in the question. 1125 plus 375, that adds up to 1500 watts in total. So we have total losses as 1500 watts. Now the question asks us to find out the efficiency. Now the efficiency, the percentage efficiency, can be written as the ratio of the power output to the power input. Now the power output would be the terminal voltage into IL, that is the current that is given in the question, divided by, now the input we have no idea of, it is not given to us, so what we can do is write it in terms of the output and the total losses. So the input equals the power output plus losses, total losses. So this would be VTIL divided by VTIL plus total loss. Let's substitute. Since it is percentage, don't forget that we will have to multiply by 100 at the end. So VT is 220, 45 is IL divided by 220 times 45 plus 1500. And that gives us 9,900 divided by, and that's 9,900 plus 1500, 11,400. That comes around to 0.8684. So the percentage eta is equal to 86.84%. So this is our final value, 86.84. I hope this has helped.